Hello, YouTube. So today we're going to be taking another look at just how much of an ecological disaster this derailment and subsequent fire was in Ohio, because this is still widely being reported as some massive ecological disaster, and all sorts of conspiracy theories well up about this, and all the politicians are sort of descending on it to say one thing or another. I don't care about any of that. I'm just going to give you the rough breakdown of what was leaked and what are the potential hazards. And a lot of people look at the big black cloud and say this is a disaster because it looks bad. And to me, I don't really care so much about the stuff that's burnt off for reasons I'll come to shortly. The stuff that's on the ground, you see there's a lot of derailed cars here. The oil, if there's oil or stuff in there, that's probably a bigger environmental hazard than the toxic chemicals that were leaked. And again, I've got no real dog in this fight. If the derailment obviously happened for a reason, it's obviously caused a lot of damage, and whoever is responsible, yeah, you should regulate these things, learn from these mistakes. Um, but ballpark figures. Let's take a look at the chemical that was actually leaked, which was vinyl chloride. So I'll put my carbons in there for the moment. Vinyl chloride looks something like this. Uh, and when you burn it, right, this stuff is fairly volatile. It's about the same physical properties as gas lighter fluid. So, you leave it unattended for a few minutes, it'll all evaporate into the air. The chemical itself is pretty noxious stuff. For certain, you wouldn't want to be anywhere near this while the stuff is venting into the atmosphere. But the atmosphere is fairly big, dilutes stuff fairly well. So, as long as you're not local to it, that wouldn't probably be too much of a problem. In terms of environmental damage, it's a gas, this stuff, but, like all stuff, it'll dissolve in water, and because of the actual nature of this chemical, it's fairly toxic. So they made the decision that they were going to burn it off. And when you burn the stuff off, the carbons go to carbon dioxide. The hydrogens mostly end up in water. Not all of this stuff is essentially harmless. And the chlorines end up as HCl, hydrochloric acid. Now, there was roughly 100 odd tons of this stuff ish. Somewhere between 1 and 500 tons. I'm just going to keep it at 100 tons to keep my numbers simple. Right? And of this, so how much HCl would we get out of this? Well, chlorines were about 35, and, all this is carbons are 12, so it's 20, 30-ish. I'm going to say it's about 50% by weight chlorine, and I'm not even going to bother with that. I'm just going to say the whole thing that was leaked is 100 tons of hydrochloric acid. That's probably not far off correct. So, how damaging is 100 tons of hydrochloric acid to Ohio? So, if we come back to our train wreck and we take a look at the size of Ohio, and Ohio is 100 billion meters squared, and we're going to take a look at the rainfall, typical rainfall for Ohio, which is, according to this, about 30 inches per year. It's about a meter per year, which is actually very nice for our numbers. So, Ohio is, what is it, 100 billion. 100 e to the 9 billion meters squared. And if we get 1 meter per year, so that's now one of these boys, that's going to be 100 billion cubic meters of water per year, and 100 billion cubic meters cubed is tons. A meter of water, cubic meter of water weighs a ton. So it's 100 billion tons of water falls on Ohio per year. So per day, it's going to be this divided by 300. So that's going to be 300 million tons of water per day. And we have 100 odd tons of HCl to dissolve in that. We'll come down to the local concentrations in a second. Let's get me a new sheet. So, water goes, acidity goes on a scale called pH, which is basically the sort of concentration of acid in your solution. And with HCl, the chlorine just dissolves in these solutions as chloride, no different from sort of sodium chloride. It's the acid is the dangerous stuff, but we're going to go on the basis that every chlorine that you put in there is an acid, and roughly, if you have 1 part in what is that 2? Right, so 1 part in 10 million is pH 7. That's basically natural. That's pure water. And the way the pH scale goes is every notch on the pH scale is an order of magnitude in concentration. So at pH 6, it's 1 part. Actually, that's 10 in 10 million. 1 in 10 million. pH 6 is 1 in a million. Let's go like that. So 1 part in a million is pH 6. pH 5 is 1 in 100,000. 4, 3, e to the 3, 2, e to the 2, and 1 to the power of 1. So it's something like 1 part in 10 is pH 1, I think. It's along those lines. Anyway, so where on this, so down here, you're at basically battery acid, that sort of thing. Here is pure water, and somewhere in the middle, around here somewhere, is like lemon juice, which is actually pretty toxic stuff. You put your fish in lemon juice, they don't live very long. And so we had, what was it? 10, no, it was 100, 300 million tons of water per day was the rainfall on Ohio, and you have 100 tons of HCl dissolved in that. So it's about 1 part in a million. You're in this sort of region, which is, and that's assuming that it's just diluted in all the water in Ohio over a single day. Not quite true, of course, in that, the way these things burn. So you have your fire here. The heat and the such like the fire makes it go up. You saw that in the big plume of burning stuff, and then it sort of drifts down stream and it dissolves in the water as it goes, and eventually some of it'll come back down to earth. But my expectation would be that it actually takes quite a long time to come down, and the water going through the rivers will dilute the acid very quickly. So the HCl, as a general rule, or any acid spill like this, dilution kills it pretty quick. You expect locally where there are high concentrations of acid, you're going to kill off the fish life and that sort of thing. But long term, there's basically no damage. Within everything will come back very quickly. There's no long term hazard from HCl. once it's washed away or been diluted. And you bear in mind this, if you dilute it over all of the water in Ohio over a single day, you're basically at harmless levels. Over several days, dilution just kills these things. So probably the more long, or another way to look at this, right? Let's do another one of these just to give you some idea of what dilution does for you. So if we come back to our screen here and we take a look at the population of Ohio, it's 10 million odd people. Okay, so let's go for that. 10 million people. 10 million people. And let's say they all wash their hair one time per day with 10 grams. That's a relatively small amount of shampoo, that sort of thing. So 10 grams is 0.01 kilograms, and so that's 100th of a kilo. And so that means that if you've got 10, 3, 4, 5, 6, that's your people in Ohio, and you're using 100th of a gram per day. This is how many grams of shampoo you put into the water supply every day, which is 100 tons. So, the expectation is you're dumping huge amounts of stuff like that into the water supply on a daily basis. And, this would also go if you were adding bleach to the bleach is something like that. But, you'll be dumping similar amounts of all of these chemicals into the water supply on a daily basis. And it's decentralized. And a lot of this stuff, when it's diluted, these are things that the wildlife can live on. So the stuff that would probably bother me more if I'm looking at stuff to be worried about here isn't so much all of the stuff that's burnt off, right? Because that's now mostly carbon dioxide, which is harmless, water, which is harmless, hydrochloric acid, which dilution kills fairly quickly. The black smoke, on the other hand, this tends to be evil, carcinogenic, burning plastic. It's you get these polyaromatic hydrocarbons, which tend to be pretty noxious, carcinogenic stuff. But again, it'll be spread over a large area. The stuff that would bother me more is if there was any stuff in all of these rail cars that can't be burned off. Right, so the vinyl chloride that they burned off has a similar volatility. Basically, they had two options. You could either let it evaporate off slowly, which would have dumped all of the vinyl chloride, which is much more toxic, into the atmosphere, or you can burn it. Either way, it would have gone by the time they'd managed. It's volatile, yeah. They unless they were keeping it in pressurized cans, it would have evaporated off at some point, or the rail cars, if they weren't pressurized, would have pressurized and exploded. But it's what was the other stuff in there, right? So if you just were transporting regular, fuel oil or some stuff, that will be a much bigger environmental problem, in that it's not volatile, so it won't just evaporate on its own, and it will take forever to disperse. It won't, fundamentally it's still like only going to be a few hundred tons or something, but it's more like an oil spill now. And the problem is with these, with things like fuel oil, is it lingers in the environment. Eventually the bacteria will eat it and the such like, but until then, that's also fairly toxic to the wildlife and the such like. So anyway, those are just some quick thoughts on why yeah, all the big plumes of smoke and you having hydrochloric acid coming out of the atmosphere doesn't actually bother me so much because dilution just kills it. Anyway, so yeah, I hope you found that useful, and I will see you next time.